Sorry, earlier my surface, something wrong with my surface. I had to stop the video and now I can start it over. Let's look at example 2. We were talking about the index number, right? Index number is 2. So we're gonna raise both sides to the power of 2. And the square cancel out the square rule. We have x plus 5 on left hand side. Right hand side, x plus 5 to the power of 2. You could either do FOIL. You know, square is exponentiation is a repeated multiplication. You have a square here means you have a product. In a product, you're going to use x plus 5 twice in the multiplication. So I'm going to do this quickly. X times x is x squared. Outside 5x. Inside 5x. Last 25. So you would end up with x squared plus 10x plus 25. Some of you might remember this formula. A plus b to the power of 2 equals a squared plus 2ab plus b squared. Of course, you could apply this formula and you would have the same thing. So we would have x squared plus 10x plus 25 on the right hand side. Now I'm going to move everything to the right. I copy whatever on the right. I move this x over, I have a negative x. I move this 5 over, I have a negative 5. And then I combine like terms. X squared, copy it. 10x minus x, 9x. 25 minus 5, 20. And now I switch the two sides. X squared plus 9x plus 20 equals 0. Okay? You know, we have learned the technique to factor a quadratic trinomial with the leading coefficient 1. The name of the method is called the shortcut method. Apply that method, you could FOIL, you could factor the left-hand side as x plus 4 times x plus 5, because 4 and 5 multiply to 20 add up to 9. And you would have x equals negative 4 or x equals negative 5. Are we done? Or did we finish for this problem? If you look at the guideline, what does the guideline say? Do we need to check? Do we need to check the result? Yeah, we have to check, okay? The last step. We have to check. And we do have to plug the proposed solutions back into the original equation to see if they satisfy. So the original equation is square root x plus 5 equals x plus 5. And we're going to plug in x equals negative 5 here. Negative 4 here. Negative 4 plus 5. Negative 4 plus 5. Negative 4 plus 5 is 1. So we have root 1 equals 1. That is a true statement. So we're going to keep this solution. The other proposed solution, let's write down the original equation. And we plug in x equals negative 5. Negative 5. We have root 0 equals 0. That is a true statement. Again, we keep this one as well. So we can make a conclusion here. The solution set of the original equation, the radical equation, is a set. The solution set of the original equation is a set containing two solutions. They are negative 4 and negative 5. All right? So that's example 2. How about let's do one more. Example 3. How about this time? I'm going to give you two radicals in the equation. 2x plus 3 equals 2 minus square root x minus 2. Okay, look at the guideline. What's the first step? Isolate one of the radicals. This radical is already isolated, right? On the left-hand side. So we're going to raise both sides to the power of 2. And we would have 2x plus 3 on the left. On the right-hand side, you know, you could either apply for u, or you could apply this formula, a minus b to the power of 2 equals a squared minus 2ab plus b squared. I know some of you knows this formula. It would be more convenient for you if you apply this formula instead of for you. And I'm going to do this quickly. I would have 2 times 2 is 4, minus 4 square root x minus 2 plus x minus 2. Let me double check. The square of 2 is 4. The square of the radical is x minus 2. Subtract twice of the product of them. Okay, everything looks fine. You know, for the detail, you can for you. You see, just apply for you to see if you have the same result. Okay, that's the result on the right-hand side. I have so much stuff in this equation, and I have one radical only. So by the guideline, I'm gonna move that radical over. Negative becomes positive, 4 square root x minus 2. And everything else gonna go to the right-hand side. Copy 4, copy plus x, copy minus 2, and move those two terms over. Minus 2x, minus 3. Combine like terms. X minus 2x, negative x. 4 minus 2, 2. 2 minus 3, negative 1. So do you have negative x minus 1 on the right-hand side? So you see what happened now? We actually just eliminated one radical. We had a 2 originally. Now we only have a 1. And that one is isolated on the left. We're going to repeat step 1 and step 2 in the guideline. We raise both sides to the power of 2. Square of 4 is 16. Square of the radical is x minus 2. Here, I actually applied a formula that you have learned from Algebra 1. It's chapter 5. It says power. I'm going to use 2 as a power. Let's say the power is 2. It's called the power of a product. Power of a product equals the product of powers. Okay? So you're going to have the square of 4, which is 16. And then multiply square of the radical, square root, which is x minus 2. On the right-hand side, yeah, this problem is a bit challenging. It requires a lot algebra, basic algebra. So I'm gonna for you this or whatever formulas you wanna apply. You could apply this formula. A plus b to the power of 2 equals a squared plus 2ab plus b squared. And then we would have x squared plus 2x plus 1 on the right-hand side. Distribute on the left, 16 times x, 16x. 16 times negative 2, negative 32. X squared plus 2x plus 1. Okay? Everything goes to the right. X squared plus 2x plus 1 minus 16x plus 32. Combine like terms. X squared by itself. 2x, negative 16x, they are like terms. We combine them, we have a negative 14x. 1 plus 32, 33. Switch the size. We get used to right-hand side 0, right? Okay, on the left right now we have a quadratic trinomial with a leading coefficient 1. Shortcut method. You might ask, could I use a quadratic formula? Yes, you could. Whichever method you prefer. So apply my shortcut method, you would figure out, because that we covered that in previous chapters. We are not going to spend too much time here. The two numbers are gonna be both negative, -3 and -11, because the -3 and -11 multiply to +33, add up to -14. So we would have x equals 3 or x equals 11. 3 is the opposite of -3. 11 is the opposite of -11. So since you could actually pause the video and then continue and we'll repeat it, I'm not gonna try to slow down because I feel like my service does not hold too long. It has been have some problems. Sometimes it just died suddenly. So x equals 3 or x equals 11. Well, one more step, check. Okay, very important. This step is mandatory. If you don't have that step, you might end up with a wrong answer. We have 3 and 11, but those two are just propose the solution. Okay, propose the solution. Yeah, let me copy the original equation. You can see it from the notes. Square root of 2x plus 3 equals 2 minus square root of x minus 2. Let's plug in x equals 3 here. 2 times 3 is 6. 6 plus 3 is 9. Root 9 on the left. 3 minus 2 is 1. Root 1 is 1. 3 equals 1. Yeah, what is that? We have a contradiction. Do you see that? What does that mean? 3 not equal to 1. We are clear about that. Means x equals 3 is not a solution. It is extraneous. What about the other one? Let's check the other one. Square root 2x plus 3 equals 2 minus square root x minus 2. Plug in x equals 11. Two times 11, 22. 22 plus 3, 25. You figured it out. You use your calculator. 11 minus 2, 9, right? 5 here. The square root of 25 is 5. Square root of 9 is 3. We end up with 5 equals -1. That obviously is a contradiction as well. So 11 is extraneous as well. We only have two proposed solutions. They are both extraneous. So what's the solution set? When you conclude, the solution set is empty. Or you can say no solution. Okay? You can see how important it is to double check your result. However, I had this example on my notes. However, if the radical equation, let's say that's my example 5 in the notes. Let's look at this equation. Yeah, suppose the root number of the radical is 3. 3 is odd. Actually, technically, you don't have to check. Yeah, we need to check the equation, which you have to do because the radical in the equation that we gonna work on always be 2 square root. So it's even number. You would have to always check your proposed solution to remove the possible extraneous solutions. But what if you have a cube root here? Technically, you don't have to check. Okay. All right. Now let's move on to section 9.6. The title of 9.6 is functions with radicals. If you look at my notes, you would see this paragraph in the color of, I think that's green or blue, green. Yeah, it has the definition for a radical function. Radical function is defined as any function which can be written in this form, in which the radicand contains a variable expression, means the variable x is in the radicand of the radical. So if a is even, then the domain of this function, what is even? Everybody knows that. 0 actually is even, but if we only consider positive integers, n could be 2 or 4 or 6 or 8 or 10 and so on and so on. If n is an even number, then the radicand has to be non-negative. Okay? If n is odd number, let's say 3, at least it has to be 3, right? If n equals 1, then we don't actually have a radical. If n is 3 or 5 or 7 or 9 and so on, then we have no restriction for the radical function. So the domain is gonna be all real. But if the root number of the radical is even, then the domain has to be all the values of x which satisfy the radicand bigger than or equal to 0. For example, find the domain for the following functions. We have, in my notes, we have 4 of the problems. How about let's just do 2 of them. Yeah. Find domain and range for the following functions. The first one, y equals square root of 2x plus 1. What did we just say? If you have any problems, you can email me. If anything here is not clear, is a real number line. And let's say negative half is right here. Numbers to the right of that number. And equal to, bigger than or equal to. So including the point negative half. All right, so that is one piece. Remember, how do we define interval? Interval is one single piece on the real number line without any disconnectives. You don't have holes, you don't have any bricks in the middle, so that is one piece. And that piece has the left endpoint negative half, right endpoint a positive infinity. We're going to apply a bracket to frame a negative half because the negative half is included. So about the interval, we have talked about interval. Actually, 2x plus 1 is linear, is increasing. You can see as x increases, 2x getting bigger. As x getting bigger, 2x getting bigger, 2x plus 1 is getting bigger. So it's increasing. So y, you take the principal square root also increasing. The minimum value for x is a negative half. If you plug in x equals negative half, you would have the radicand be 0. So y is the range of the function where the values of y, minimum value is 0. All the non-negative values, all positive real numbers including 0. So that is range. Okay, that is range. I have more in my notes. You can try to practice. Okay, that is range. I have more in my notes. You can try to practice after you repeat those examples. Number 2. The function here is a radical function. The radicand is 4x minus 9, but the root number is 3 this time. 3 is odd, right? 3 is odd. 3 is odd. So how do we find the domain range? Whenever we need to find the domain, we need to consider the restriction. Restriction, remember? I typed it out in the class and asked you to, I made you guys to copy it down on your notes. Restriction. We don't have any restriction for the radicand if the root number, if the index is odd. So the domain is all real in this case. Range is all real as well, okay? That's for this problem. Okay? And you could try to use a graphing calculator to graph those radical functions and look at their domain and range. However, a graphing calculator is not allowed in the final, but it doesn't mean you cannot learn from it if you have one. So that's everything about section 9.5 and 9.6.